Now, chances are you've knocked something off a table before. Now, whether you accidentally knocked it off and it fell on the ground with little to no consequence, or physically smack it off a table, such as when you were little, potentially leading to much greater consequences, or even just watching a ball roll off a table as you're trying to play with your dog, a petty event such as an object falling off a table is so common that we really don't stop to think about the physical sciences behind such phenomena. That got us thinking, can we use kinematics to predict the displacement of a rolling object? Our setup was simple. We had a ramp to give the ball some measurable speed, 2-meter sticks to act as a stability track, and a meter stick on the ground to provide as a reference for our sensing equipment. Our goal was to determine a critical initial velocity Vi, when the ball leaves the table, and use the height of the ball to find the time the ball spends in the air, t. From there, necessary calculations would be made to determine the ball's horizontal displacement, delta x.
To determine the horizontal displacement, we must first break down the initial velocity into its x and y components. Prior to rolling off the table, the ball is only moving in the horizontal plane, so the initial velocity in the x direction will be some positive value, and the initial velocity in the y direction will be 0. Delta t, the time it takes to hit the ground, and delta x, the horizontal displacement, are the two values we are trying to find with kinematic equations. To determine delta t, we must first use the equation which focuses on the y component of motion. Since the initial velocity in the y direction is 0, we can ignore the first part of the equation. Acceleration in the y direction is freefall acceleration, as the gravitational force of the Earth pulls the ball to the floor. We simply solve for delta t by isolating delta t squared on one side and taking the square root of both sides of the equation. The same equation will be used to determine the horizontal displacement algebraically, just using x components. The ball leaves the table at constant velocity, so there is 0 acceleration in the x direction. So looking at our data, we conducted 3 runs in our experiment, and each ball was released with a different initial velocity. The time it took to hit the ground theoretically was half a second, but our actual values were about 0.1 short, or a 15.3% discrepancy. Our horizontal displacements also fell short, and that had about a 16.6% discrepancy. So what went wrong? The main source of this error was when the ball was going down the incline, it would bounce up as soon as it hit the table. Also, video physics records at 30 frames per second, which means that there might be a frame where the ball lands, but the camera doesn't actually capture that, so we had to kind of anticipate or guess where that ball would actually land, which led to another source of error. Despite these potential errors, we were able to apply kinematics to everyday motion and learn about how physics plays a role in our daily lives.